This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
So thanks everyone for attending Thitiwit's master's oration. So he's come on a very long journey. We thought it would be quick, but COVID got really in the way of his master's. So Thitiwit's a government vet from Thailand, and he joined us on a scholarship from their government and took a major role in this project of ours, Commonwealth-supported project, tracking down pigeons to look for paramyxovirus, which was partly risk assessment for the poultry industries. So Thitiwit is a bit of a youngster. He's finished his DVM at Kasetsart Uni in Thailand in 2012, then did a One Health Masters for a year, and has joined us pre-pandemic. So I think it was 2019. Was it, Thitiwit, when you started?
Yeah, November.
So it's a master's, November 21. A master's that's dragged on a lot longer than it should have, but COVID really got in the way of him doing a lot of field work. But he's persisted, and very happy to see him heading towards write-up, which is due very soon. So take it away, Thitiwit, if you like.
So shall I start now?
Yep.
All right. Okay, good afternoon, everyone. My name is Thitiwit Noinamtieng. I'm a master's student supervised by NK and Simon in EP Group and Gemma from ACDP. Today, I would like to present all my research. The title is Pigeon paramyxovirus type 1 or PPMV1 in feral pigeons in Victoria. I will start the presentation with introduction, followed by the research question and aims, and then I will go for research chapter 1 and research chapter 2. And feel free to ask my questions after I finish the presentation. For introduction, let's start with the Newcastle disease. Newcastle disease is an infection of poultry with highly virulent strain of avian paramyxovirus type 1 or Newcastle disease virus. The highly virulent strain is divided by World Organization for Animal Health as the virus has the intracellular pathogenicity index in the O6 of 0.7 or greater, or the virus has multiple basic amino acids at C-terminus of fusion protein and phenylalanine at residue 117. For Newcastle disease virus, there are two strains of NDV, class 1 and class 2 strains. Class 1 consists of single genotype, while class 2 are more various and contain 18 genotypes. And one of the most diverse genotypes in class 2 is the genotype 6, which is responsible for Newcastle disease in pigeons and referred to as pigeon paramyxovirus type 1 or PPMV1. PPMV1 structure is similar to Newcastle disease virus, which has 6 structural proteins encodes the virus genome. The PPMV1 was first detected in domestic pigeons in Iraq and in 1977 before spreading worldwide, including in Australia. A detail of incursion of PPMV1 into Australia will describe in the next part. This slide is epidemiology of PPMV1. I will start with distribution. The virus distributes throughout the world except Antarctica, and it was detected in many countries such as Italy, the UK, Belgium, Denmark, Switzerland, Netherlands. For Asia, China, Japan, India, and also in Australia. Hosts of the virus are various, but mainly found in birds in Columbidae family, which are pigeons and dove. PPMV1 was also reported in poultry and other wild birds as sparrowhawk or falcon. Transmission is more likely similar to those infected with NDV, which is via direct contact and indirect contact. For the direct contact, is interaction between normal birds and sick birds. For the indirect contact involve the contamination via personal equipment or feed. Cause of infection, the incubation period range from less than 1 week up to 3 to 4 weeks. The morbidity rate is 30 to 80% and mortality rate is 10 to 80% depending on age, species, or its immunity. Prevalence in free-living pigeons in Chile was 22% and prevalence estimate in feral pigeons in Croatia was 24.3%. For clinical signs are very dependent on host susceptibility and virus strain. The most common clinical signs in pigeons are depression, lethargy, torticollis, which is the head tilt, and tremor at wing or head. And other clinical signs can be seen such as vomiting, polydipsia, polyuria, or watery diarrhea. To diagnose PPMV1, the techniques are similar to Newcastle disease diagnosis and refer to the OIE Newcastle disease manual of diagnostic tests and vaccine for terrestrial animals. The techniques include clinical appearance, serology tests, molecular techniques, and virus isolation. The research questions are how prevalent is PPMV1 among feral pigeons in Victoria, and what is the potential risks of transmission from infected pigeon to commercial poultry. Consequently, my research aims are to estimate the prevalence of PPMV1 in feral pigeons in Victoria and to investigate potential route of virus shedding. I would like to go to the research chapter 1, which is the review incursion of PPMV1 into Australia. PPMV1 was first detected in Australia in August 2011. However, the effect cases were recorded individually by each state government and lack of the comprehensive picture of the virus emergency in Australia. So it is important to understand how virus spread across the country and for informing the response. So this chapter aims to gather and correlate PPMV1 data from 2011 to 2021 from all Australian states in order to describe the incursion and spread of PPMV1 into Australia in details. Bacterial and methods. Data of domestic birds were recorded by Animal Biosecurity Authority in each state government, while data in wild birds were recorded by Wildlife Health Australia. Also, data from case submission from Australian Centre for Disease Preparedness or ACDP were requested once I got approval from the state government, and other data was from published literature. And all these data were requested in terms of investigation date, effect location, infected species, number of infected birds, and during August 2011 until March 2021. And the received data were cross-validated with the case submission data from ACDP, and the data that could not be matched with the government data were removed since there might be multiple submissions to the ACDP. And the received effect postcode were geocoded by our statistic package using Google Way library, and all data were analyzed and reported in aggregate form as epidemic curve in Microsoft Excel and create descriptive mapping via QGIS program. These are results. A total of 236 infected locations from August 2011 to March 2021 were received. With this number, 83% was domestic pigeons and 16% was feral pigeons, and only a few number were other wild birds. And this is the timeline of PPMV1 in Australia. The virus was found in all Australian states except Northern Territory. It first detected in resting pigeons in Victoria in August 2011, and then spread to feral pigeons in October same year. For New South Wales found the same spreading pattern as in Victoria, which is the first detected in domestic pigeons in 2012, and before spreading to feral pigeons in November 2012. In Tasmania, where virus spread to Tasmania in June 2013, and in 2015, one pigeon frog was detected in Perth in Western Australia, and once again in November 2018. And the virus came to South Australia and Queensland in 2016, and finally, the first detected in feral pigeons in Australian Capital Territory in 2018. And these are biosecurity measures implemented after detection, which were similar in each state. The biosecurity measure comprise practicing personal hygiene, cleaning and disinfecting personal and bird equipment, including vehicles, and quarantine of new birds introduced to the farm, and also vaccination to birds. And the disease progression of PPMV1 infected location are depicted as in epidemic curve, and the overall pattern of epidemic curve appear to be a point source epidemic with a rapid increase of infected location, followed by a slower decrease. And from 2014 to 2021, the infected location were continuously detected, and the epidemic curve turned into endemic. So if we look at the Victorian and the orange one, the epidemic curve pattern start with same with the point source outbreak, with the peak in September 2011 and become sporadic after effective implement of the biosecurity practice in 2012. For New South Wales, with the green color, New South Wales pattern is start with the point source outbreak, but the virus continuously detects. So the latter pattern was changed to endemic rather than sporadic as in Victoria. It's different. And this is a descriptive mapping of infected location in Victoria from 2011 to 2020 in Victoria. And Victoria had 115 infected locations, which is the highest number compared to those other states. The round point in the picture represent the domestic birds, and the round point with the dot in the center was wild birds. Wild birds include feral pigeons and other wild birds, but mostly feral pigeons. PPMV1 was first detected in a pigeon loft in Shepparton before spreading downward into Melbourne Basin. However, there is no evidence that how the virus was introduced into Australia. One of the known source of infection was from a pet shop, where these pigeons were purchased from the pet shop, and many of these pigeons were admitted to a veterinary clinic, which became a focus of transmission because of close contact between sick pigeons and healthy pigeons in the clinic. And the virus spread to feral pigeons 2 months after first detected in domestic pigeon. And also other wild birds, such as spot turtle dove and a coral sparrowhawk, has been seen from the analysis. And most of the cluster appear to be tightly in the urban areas in Victoria. For New South Wales, New South Wales detect PPMV1 every year since April 2012. The first location was in Crampton Park. This is the blue star. The importation of this bird from Victoria was considered the likely cause of outbreak in New South Wales. The virus spread rapidly to Greater Sydney in a few months later, and in New South Wales started with domestic pigeon and spread to feral pigeons in November 2012. And as I mentioned in the epi curve, the outbreak pattern in New South Wales seemed become endemic after the first point outbreak in the initial of outbreak. and most of affected birds were domestic pigeons, while only just 4% of the report were feral pigeons in New South Wales. And similar to Victoria, the spatial pattern in New South Wales was highly clustered in the urban area. Discussion. This chapter provides a summary of PPMV1 incursion into Australia. The epidemic curve presents the initial point source epidemic, suggests that the virus was new to Australian pigeons, resulting in rapid spread. And after effective biosecurity measure implement, the rate of new infected locations were reduced and the epidemic curve pattern turned to endemic. However, the epidemic curve pattern in Victoria is different. The pattern starts with the initial point source outbreak, but becomes sporadic, and surveillance of the virus in feral pigeons is limited in Australia or in Victoria. So only sporadic reports are received. The cluster spatial pattern of infected location in Victoria and New South Wales is likely due to pigeon loft that normally being close together and usually around urban area. So the infection of feral pigeons was also commonly found close to domestic pigeon loft via interaction between domestic pigeon and feral pigeon. Or infection of feral pigeons usually found in the area of high human population. All right, I will continue to slide 22. For discussion, another issue is the detection of PPMV1 in Australia was first seen in domestic pigeons and later spread to other wild birds, including feral pigeons. This pattern also found in other countries such as Italy and the UK. And Pearson reported that feral pigeons in the US received PPMV1 from domestic pigeons via interaction. PPMV1 is a risk to cause Newcastle disease in poultry, as reported in the UK and Macedonia. And however, there is no detection of pigeon-derived Newcastle disease to Australian poultry so far. Also, there is no surveillance specifically to PPMV1 in Australia. And another one is biosecurity practice. Workers state that the virus was introduced into Australia because it's most likely related to the legless biosecurity at Australian border. However, the exact cause of disease spreading was not possible to identify from this study. Okay. I'm going to the research chapter 2, which is the investigation of PPMV1 in feral pigeons in Victoria. And since I mentioned that there is no specific investigation for PPMV1, so this study is a pilot survey of PPMV1 in feral pigeons in Victoria. And this aims to estimate prevalence of the virus in feral pigeons and to investigate the potential route of virus shedding. Our detail of the virus have been mentioned previously, so I would like to go through the material and methods. This project was approved by UNIMEL Animal Ethics Committee. The sample size was calculated using our package EPR available online with two-stage cluster sampling designs. The assumed prevalence from the previous study in Croatia being of 24.3%. With the design precision of 10% and 95% confidence level. With the 0.135 intra-class correlation and estimate pigeon population size of 1 million. The result depended on the number of pigeons trapped per location. If 20 pigeons were trapped per location, then 252 pigeons would be required from 30 locations. But if 15 pigeons were taken per location, then 204 pigeons would be required in total from 40 locations. And If 10 pigeons were sampled per cluster, then 157 pigeons would be required from 16 locations. Sampling method. The target species is feral pigeons and rock dove, Columba revier in Victoria, disregarding sex and age. The pigeons came from two main sources. First is pest control company provided, and the second is I catch them by myself via trapping or using alpha-chloralose bait. Sampling locations were mainly around poultry locations, so that the risks of PPMB1 to chicken is more likely to assess. Poultry farms were got in touch by mail address available at the farm transparency website. Or discussion from my presentation to the Victorian Poultry Health and Welfare Liaison Group, and through networking with colleagues here. And I have sent mails and emails to farms and follow up by a phone call. For the using of alpha-chloralose, it was used with the pigeons in urban area where there were many pigeons around and really less with the non-target species. I mean only feral pigeons. And this slide, I show you trapping locations that I have installed them. See the blue point in the map. But yeah, not all of them was successful. And the background of the Victorian map is chicken density per pixel from graded livestock of the world global chicken distribution. And this slide is trapping process. A trap was installed at the farm with location that pigeon usually appear. And I put the pigeon crane inside and keep the trap window open at least 1 week to make pigeons familiar with the trap. And pigeon also can get in and get out freely. And I have set up an outdoor camera close to the trap so that I can monitor species of birds, time that they appear, and how many of them. On the trapping day, I put the feed in the trap and then I close the window so the pigeon can get in but cannot get out. And I have monitored the trap via real-time camera, or otherwise I would walk to the trap and check it every 30 minutes due to the animal ethics approval. Using alpha-chloralose bait. Alpha-chloralose is a narcotic drug that has been used to control birds. And I use the alpha-chloralose only in urban area, as I mentioned. And there are two forms of alpha-chloralose used in this project. The left one is paste form, which has lower concentration, but it is easy to use. It just spread on small pieces of bread or biscuit and fed them by my hands or put in the container or plate. And yeah, it might take longer time compared to powder form. I would say it might take like at least 30 minutes to make pigeon loss of conscious. And the next one is powder form. It is 98% concentration, but it needs to be mixed before using. It was mixed by 6 grams of alpha-chloralose powder with the 600 grams of pigeon feed. And I put in the container and the closed container and mix them. And yeah, and then add further 10 mils of corn oil and shake once again until well mixed. And then I fed pigeon in a container and monitor them closely. Once pigeon had the sign of loss of consciousness, and I took them into a closed cardboard box with a small hole to like make the air flow a little bit. And this is the way to collect sample. Pigeons were euthanized by using overdose of isoflurane, and I put the 2 pieces of cotton swab ball, not cotton swab. I put 2 pieces of cotton balls into a small glasses of bottle, and then I pour the isoflurane around 3 to 5 mils into the bottle, and then I place the pigeon heads into the bottle and hold it for at least 15 minutes from my experience, or until pigeon die. To ensure that pigeon die, cervical dislocation was conducted afterwards, and then I collect sample from pigeons. Firstly, I use the sterile cotton swab taking from cloacal and oropharyngeal, and then I place the cotton swab into the VTM viral transport media and keep it at -70 until testing. And for the blood collection, I usually use cardiac puncture to get the blood from pigeons, and I took like 2 or 2.5 ml from each pigeon and put into a serum tube. And the serum tube, the big tube, were kept in the fridge for 1 or 2 nights, and then I spun them to separate serum from the whole blood using centrifuge with the 2500 G for 15 minutes. And then I put the serum into microtube and store the microtube serum at -20. All samples were tested at ACDP or AAHL, and the serum samples were tested by hemagglutination inhibition test or HI test with 2 kinds of antigen comprising NDVB4 and ppmb1 isolated from Victoria in 2011. The swab sample were tested by qPCR. The positive qPCR then were tested by virus isolation. The statistic method used in this study comprising chi-square Fisher exact test, package EPR for the true prevalence estimate using Logan-Garden formula, and for the odds ratio used for compare statistical difference between regions via a statistic package. The phylogenetic analysis were performed on the full range of virus nucleic acid sequence data provided by ACDP. To compare the isolated virus from this study to other paramyxovirus, phylogenetic data was downloaded from GenBank to encompass all relevant F-gene sequence from study by Chan and Dimitrov. The download data were imported to Mega Software version 11 for analysis, and the maximum likelihood phylogenetic tree was constructed and annotated. The virus isolated from this study will perform the variation analysis in terms of single nucleotide polymorphisms or SNP with the synonymous SNP and non-synonymous SNP compared to those other reports in Chance and colleagues in 2021. All right, let's come to the result. Overall, there were 182 feral pigeon samples from 11 different locations in Victoria from January to December 2021. The pigeons from each location are present in the table, and the location were divided into 4 regions, comprised Southeastern, Central region, Eastern region, and Western region. For the seroprevalence result, the results show more serological positive on HI-ppmb1 than HI-NDV. Overall, there were 82 samples positive HI-ppmb1 and 79 samples positive NDVV4. Of these 82 samples, 64 were positive both HI-ppmb1 and HI-NDVV4, and 54 of 64 had higher titer of ppmb1, and 10 samples had equal titers to between HI-ppmb1 and HI-NDV, and just only 1 sample that has a higher titer on NDV. So overall apparent prevalence estimate was 45% with 95% confidence level from 38 to 53, and the highest seroprevalence location were from Noble Park, and followed by Kaniki and Dandenong South. The estimate true prevalence adjusted by sensitivity and specificity value of HI-NDV was 54. So if we look at the sampling regions, the seroprevalence in Southeastern region had the highest number, which is the 70% prevalence, while the Western region had the lowest true prevalence. And the true prevalence of the virus in Central and East region was 45 and 39. And the results were compared using odds ratio. Look at the upper table. Southeast region was selected as the reference group since it has the largest samples and despite having the higher seroprevalence, which resulted in point estimate of the other odds ratio being less than 1. The odds of feral pigeon sample from East region were 63% lower than those in Southeast region, while the odds ratio of the seroprevalence of feral pigeon sample from Central and Western region were 55 and 93% lower than those sample from Southeast region. With a p-value of 0.015. And the lower table show the statistically significant difference between seroprevalence of feral pigeon sample from each region, which the Central and Western region had the statistical difference with a p-value of 0.046. For the molecular result and virus isolation, all of the oral swab tests were negative by qPCR, and there were only 3 cloacal swab samples detect ppMV1, which was 9.4% apparent prevalence, and all of these were from North Melbourne. And the range of CT value was of 32.8, 36.7, and 37.7. And all 3 PCR positive cloacal swabs were also tested by virus isolation and confirmed with the hemagglutination test. Only the sample that has CT value of the 32.8 was positive on hemagglutination after virus isolation. And the rest of samples that had a higher CT value had no hemagglutinating reactions. So this virus isolation was important for the full range sequencing of the virus genome. The genetic analysis showed that the virus isolated from this study was more likely close to the ppMV1 isolated in 2011 Australian outbreak. The ppMV1 is isolated was named as the PB49 North Melbourne at 4th of July 2021 at the Red Triangle. And this isolate was found to belong to the class 2 genotype 6, subgenotype 6.2.1122 of avian paramyxovirus type 1. The amino acid sequence at F gene cleavage site motif of the PB49 North Melbourne isolate was the RRQKRF117 and was identical to amino acid sequence of the virus sample during the outbreak and was categorized as virulent NDV. And the terminal amino acid sequence of HN gene or hemagglutinate of the ppMV1 isolate was KDRRV, which differ one site from the amino acid sequence of the virus isolated in 2011, which is KDERV. Also, the isolate virus had no HN extension after the terminal N, and which classify as virulent NDV as well. For the variation analysis indicate that ppMV1 isolate had the lowest variation to those previous 6 Australian isolates in 2011 with the SNP of 24 to 25, synonymous SNP of 17, and non-synonymous SNP of 7 to 8. So let's go to the discussion. The overall seroprevalence against ppMV1 was almost 2 times higher in feral pigeon in Victoria than feral pigeon in the previous study in Croatia and Chile. Since the sensitivity and specificity value for HI-ppmv1 were not available in the literature, so the true prevalence from this study using the sensitivity and specificity value from HI-NDV, and there might be biased estimation of the true prevalence. Almost all true prevalence estimates in each sampling location were higher than apparent prevalence estimates, with the exception at Meredith in the Western region. And this might relate it to the relatively lower sensitivity than specificity estimate available for HI-NDV assay. Or the lower true prevalence at Meredith is likely related to the low prevalence at this location or specificity value used in the calculation. And another thing is the higher antibody response to ppmv1 than V4 was likely related to cross-reaction. And this also means that feral pigeons were more exposure to ppmv1 than NDV. The infected pigeons with the ppmv1 have ability to generate cross-antibody to other NDV strains, and the use of V4 antigen aiming for identification of vaccine reaction. But however, feral pigeons were not vaccinated with the Newcastle disease. So, but yeah, they can infect the V4 vaccine strain through interaction with the vaccinated poultry. Then all of positive HI-NDV-V4 in feral pigeons with the equal or lower titer to ppmv1 was assumed to be the cross-reaction. And most of the feral pigeons in this study show highly cross-reaction to NDV, which agree with the previous work by Chan and colleagues in 2021. However, there were a few samples that positive only NDV-V4. So this is likely due to the natural infection with the V4 strain. And the ppmv1 is still potential risks to cause ND in poultry and needs to be monitored because of the virulence from genetic analysis. The results show that ppmv1 is more highly prevalent in Southeast region than other regions. The Southeast region has the high density of poultry farms and likely represent a high risk region for pigeon deliver Newcastle disease to poultry. And the seroprevalence in central and west regions were statistically different, lower than the Southeast region. And these two regions had lower poultry farm as well. So in these two regions, the risk of transmission to poultry appear lower. ppmv1 is spread through Victorian feral pigeons population according to the seroprevalence estimate. The distribution of ppmv1 in feral pigeons vary in many locations, but the finding from chapter 2 indicate that ppmv1 is sporadic at the moment, but there is surely under detection for the previous study, because the true prevalence from this study indicate that the prevalence is high in many locations, suggesting that it might be endemic exposure in Victoria. And this study finding therefore support the statement of Kowan that and he said that the ppmv1 is endemic in Australia. Although there were highly prevalent of ppmv1 in feral pigeons from this study, the detection of ppmv1 shading swab test was low, and the positive qPCR swab in this study were from only 3 cloacal swabs. As a result, cloacal secretion is a potential route of transmission of the virus in this study. And the virus isolated from North Melbourne, which is from the feed manufacturing at North Melbourne. So feral pigeon is in this location in North Melbourne are a risk of ppmv1 transmitted to poultry via feed contamination, as reported in the UK in 1984. So what is important epidemiologically is that given the high seroprevalence of ppmv1 in pigeons in the present study, The virus is being transmitted among the pigeons population in Victoria, but at any one time, just a small number of virus shedding. And therefore, there appears to be a low-level risk of PPMV1 being introduced to poultry in Victoria, especially if Newcastle disease virus vaccination still performed. The sequence analysis indicates that the isolated virus is very close to PPMV1 isolated in 2011, but distinct from the other PPMV1 isolated from elsewhere in the world. And this suggests that the virus has evolved from the earlier introduction rather than the new introduction from other countries. And also the amino acid sequence of F protein and HN protein were identical to the PPMV1 from 2011 and also identified as virulent NDV. However, several studies have indicated that using only F protein cleavage motif and terminal extension of HN protein might not be the most effective way to determine virulence, because other factors need to be considered, such as host species and virus strain. And another way to identify pathogenicity might be like ICP, intracerebral pathogenicity index. All right, this is the last slide before going to acknowledgement. In conclusion, feral pigeons in Victoria has a high seroprevalence of PPMV1. However, the virus shedding from exposed pigeons were low, and the potential route of virus shedding was from cloacal secretion. So this suggests that the contamination of chicken feed with the pigeon species cannot be ruled out. And the virus isolated in this study is closely related to the virus in 2011 outbreak and appeared to be virulent. And acknowledgement. So I have to say thank you for everyone who always supporting me, my advisory committee, my government for sponsorship, the Department of Agriculture and Fishery and Forestry for funding this project, state government for the data, poultry farms and feed manufacturers for allowing me to catch pigeon, Professor Amir for all supports, and Parisa for PC2 lab guiding at Parkview, and Jonathan from Agricultural Victoria for all support. Andrew, who's allowed me to catch pigeon at his property, Denise and Ling Shu for viral transport media and serology instruction, and also Martin at Werribee for organizing everything at Werribee campus. Dr. Jasmine for outdoor camera for monitoring pigeons, and Chumos, my friend, for driving and take me to poultry farms. And last but not least, all Melbourne Veterinary School staff for all supports. Thank you.
Well done, Thitiwit. Yeah, fantastic. You must put so much effort into your presentations, and they're very clear and well, good way to summarise everything that you've done. Fantastic effort. I'll just add one more acknowledgement there to Wildlife Health Australia. We've got Claire and Rupert here from there, and they also contributed to data. But yeah, great to see them able to join us. And actually, Rupert has asked the first couple of questions. If you audio and video are working, Rupert, you're most welcome to ask directly, or I can repeat your question.
Yeah, thanks, Simon. Nice work, Thitiwit, and way to go, Melbourne Uni, leading the charge at us all. I'm interested in management, and I've got two questions. Firstly, how important do you think this disease is with respect to the many other disease threats that are facing us at the moment? So specifically, should we be doing more, or is general surveillance and increased biosecurity awareness in the pigeon industry enough? And then my second question is, what have we learned And do you have any advice for us on how we might better approach disease incursions like this in future? So given what you now know, Thitiwit, if you could go back to Victoria in 2011, what advice might you give us or have given us then, or advised us to do differently? Thanks, Simon. There's a lot in there, isn't there?
Yes. I personally think that this virus is not most important, but not disregard. It's because from this study, the virus can be it's still the leaks, it's still the virulence. It's still virulent as NDV, but together with the poultry production system is like give vaccination, ND vaccination, so the leaks is low. But yeah, as I mentioned, the virus can be a leak to cause Newcastle disease in poultry. So yeah, it is important to continue the big scale of surveillance in pigeons. And another questions, do you have advice, right? From my study, I try to get information from like state government, but yeah, some information still limit. So if there is the new incursion, we need to, yeah, I think but Australia has the very strong biosecurity system, but even the new disease introduced to Australia, I think the data have to be like record in the same pattern. I think that should be easy to identify.
It's good to see how far you've come, Thitiwit. You answered those questions really well, given yeah, where we've brought you from over 2 years. So that's 3 years. So that's fantastic. I would have answered very similarly to a couple of Rupert's questions. So yeah, I think if anything, it helps emphasise the importance of Newcastle disease vaccination for the poultry industry, doesn't it? So yeah. Excited to see a question from Songhua here, because we've benefited greatly from your paper early on. So Songhua is asking about the antigen used for seroprevalence and the cutoff for serological testing, which I think you mentioned, but if you just want to repeat that just for clarity.
Or yeah, I will answer the question from Songhua. There are two antigens, the NDVV4 and PPMV1 isolated in 2011 Victoria.
Yeah, and the cutoffs, I think she was asking you.
The cutoff is different between two antigen. The V4 antigen, it's 8 H, the titer at 8, and the PPMV1 is 4.
She'll have to stay tuned for your paper. So all the detail will be there. I think that hopefully is I think that's similar to what you would have done in the previous Newcastle disease work in the ACDB study. I'm not sure if anyone else has got any further questions, but yeah, I think you've covered it all in my mind pretty well, Thitiwit. I think it was very interesting that the place that you got your PCR positives and isolate were from the feed mill. I think what hasn't come across from all your presentations probably is the amount of effort that it took to capture pigeons, and then the amount of work, the not getting positives except through serology. So a whole lot of work to find a very small amount of active shedding, isn't it? So I think we were thinking about that early on for risk assessment purposes of how hard it was to find pigeons around the poultry farms. Sort of says something about the risk as well. I don't know if you want to elaborate on that. But do you want to tell us, Thitiwit, about how long it took you to capture your first few pigeons around those farms? Yeah. Okay. I don't know if you can hear me. Yeah. So Rupert's got his hand up again. But essentially, it took a hell of a lot of work to capture his 200 pigeons. So it sort of says there's a low. Yeah, the interface is not as much as we may perceive. But yeah, Rupert, did you have another question to ask?
Yeah, I'm just interested in what others think about the speed of this. You know, because initially it was a sort of here it is, jumps into New South Wales, sort of burns fairly brightly, and then moves across the country within the sort of 8 or 9 year period. And if you think about that from one perspective, you kind of think, oh, wow, you know, this is the first time I've seen something like this. I guess it probably is, you know, or that we've had data to actually be able to map the spread and the sort of the way that's happened temporally. You guys, as epidemiologists, what do you think? Because there's one part of me that sort of looks at that and thinks, well, wow, look at that. It's burnt across the country in 9 years. And then there's the other part of me that sort of sits there and goes, well, these things fly. You know, it's a paramyxovirus. It's infectious. That seems incredibly slow to me. I mean, do you guys can you give us any sort of feel, knowing what you know about infectious disease and epidemiology? Do you have a sort of feel for the speed of this? I mean, do you think it's been fast, or have you been surprised by how slowly it's moved? I mean, have you got any kind of feel for us kind of lay people about how this has behaved epidemiologically on a whole of nation kind of scale?
Let's let Thitiwit go first. If you want to try and answer that first, Thitiwit.
One more question, right?
Yeah, so Rupert's asking, do you consider the scale fast or slow, and what sort of factors do you think are important for that?
The factor for, sorry, Simon, the factor for...
Do you think the spread interstate, the spread around the country over it's taken many years actually from the initial point sources, and whether you feel that was fast or slow and the importance of that epidemiologically?
I think it's gradually spread to other states, but yeah, because we didn't have like the surveillance program to the paramyxovirus, so yeah, only we just receive the data when pigeons show clinical signs or something like this.
Yeah, I think adding to what you said there, I agree. It's pretty slow in a sense, Rupert. It's really not the sort of rapid outbreak we're used to, but I think we commonly see things moving, people moving animals, leading to a lot of the rapid spread of diseases around the country. And the home range of your feral pigeons is pretty small, isn't it, Thitiwit? They're pretty lazy, I think was what he's reporting in his lit review. And so I think we amount to ecologically thinking about how quickly the disease is spreading around between sort of populations at various sites, and then very low rates. I think overall we're seeing a very high seroprevalence, but very low rate of active shedding that we could detect. So it is probably small numbers in your large pool of pigeons that are actually causing this to burn along. So yeah, there's a number of interesting factors there. I'm happy for people to leave. Claire's got a good, I don't know, Rupert, if you're happy with how we're answering that, or if you've got more to chip in.
Oh, no, I just think it's absolutely wonderful to actually see the data being used and to draw some pictures. You know, we're visual animals, and you know, to show us a picture and to use the data and to try to join it up. I mean, as you know, Thitiwit, what often happens in these incursions, you know, we're always in clear and present danger, so we're all scrambling to get over one before we get into the other, and often we don't spend the time to actually go back and actually have a look at the data and look at what we've learned. So I just think serious respect to you and to whoever thought this up, because it's you know, it's unfinished business. We can learn a lot from this one. So nice work, Melbourne.
I think it's Gemma's original grant that we inherited as she moved back to ACDP, but she's remained involved the whole way. And I think a credit goes to Wildlife Health Australia and all the other data sources. But Thitiwit, you really hit a very key point there with the systematic data collection, because you had a lot of hard work trying to bring this together to make it meaningful. And I suppose back to what you were talking about, Rupert, it is it's not the avian influenza or the JE. It's a very different sort of, and I suppose that's part ecological, part viral. So there's lots of different factors in the epidemiology, and I think we get into a mode of thinking like FMD or thinking like avian influenza. But yeah, this is a very different beast. We're pretty much out of time. I think, Claire, we might ask Thitiwit to send you an email about the other species that are affected nationally, because he's got all that data, because he put it all together, and it's good to share that back to you so it's made use of. So we might leave it there. Yeah, and thanks everyone for attending and your interest today, and well done, Thitiwit, again on reaching this point in your masters, and good luck on the final few meters up the road to the finish line. So, yeah. Well done.
Thank you, everyone, too. Thank you.
To the other meeting?
Yes.
Okay. Let me just...